Hey everyone, welcome back. Today we're diving into something pretty critical, but you might not think about it every day.
That's right.
High availability networking.
Yeah.
And this is all about how networks stay online even when things go wrong.
Exactly.
So we're going to be focusing specifically on DrayTek routers
Yeah.
and their approach to this whole high availability setup.
Yeah, they're multi-WAN and network reliability.
Yeah.
It's really a fascinating area.
So think about this, right? You've got hospitals, you've got financial institutions, you've got even like those servers that are powering your favorite online games.
That's right.
They all need us to be online no matter what.
Absolutely. Mission-critical systems cannot afford downtime.
Yeah, so no dropped calls, no interrupted transactions, no lag in your game.
Exactly. And that's where high availability comes in.
Right.
So what we're going to do is we're going to look at how this works, specifically focusing, as we said, on DrayTek routers.
Oh, yeah.
Now, we've got a great technical document from DrayTek, which goes into a lot of detail about how to configure this, and even a demo video showing it in action.
That's awesome. I'm already excited to see that.
Yeah.
But let's start with the basics.
Okay.
What exactly is high availability and why is it so important?
Sure. So high availability, put simply, is all about redundancy.
Okay.
It's kind of like having a backup generator for your house.
Right.
If the power goes out, the generator kicks in and you don't even notice the interruption.
Right.
So in networking, high availability means having redundant hardware and software in place, ready to take over if the primary system fails.
Okay, so it's like having an understudy waiting in the wings, ready to jump in and take over the role at a moment's notice.
Exactly. That's a perfect analogy.
I like that.
And the beauty of it is the transition happens seamlessly.
Okay.
The network traffic is automatically rerouted to that backup system.
Got it.
And users experience little to no disruption.
So no more frantic calls to the IT department.
Hopefully not.
When the internet goes down.
Right.
So how does this actually work in practice? Now, I noticed in the document they mentioned something called CARP, C-A-R-P.
Yes, CARP, C-A-R-P, stands for Common Address Redundancy Protocol.
Okay.
And it's a key technology behind how DrayTek does high availability.
Okay.
What CARP does is it allows multiple routers to share a single virtual IP address.
Okay.
So think of it like a shared phone number for all of the routers in the group.
Okay, so if they share the same IP address, how do the devices on the network know which router to talk to?
So that's where the virtual MAC address comes in.
Okay.
MAC, M-A-C, stands for Media Access Control.
Got it.
And each device on a network has a unique MAC address.
Right.
And the routers use this in conjunction with the virtual IP to direct the traffic correctly.
Okay.
So when a device tries to connect, any of the routers can respond,
Right.
but only the one that's designated as the primary actually handles the connection.
Okay.
And if that primary router fails, another router seamlessly takes over the virtual IP address, and the devices on the network never know the difference.
Wow, that is some behind-the-scenes magic to keep everything running smoothly.
It is.
Now, I also saw that they mentioned something called DARP.
Yes.
D-A-R-P.
DARP, D-A-R-P, that stands for DrayTek Address Redundancy Protocol.
Okay.
And this is actually a protocol that DrayTek developed themselves.
Okay.
And it's responsible for all the communication and the negotiation that happens between the routers.
Got it.
So it lets them figure out, who's the primary, who are the backups.
Okay.
They're constantly monitoring each other, exchanging these heartbeat messages to make sure everything's okay.
So DARP is kind of like their secret language they're using to coordinate everything?
Exactly. It's their way of communicating.
Awesome. I see in the document they talk about two different types of redundancy.
Yes.
They have what they call hot standby and active standby.
That's correct.
So what's the difference between these?
So the difference lies in how the routers are connected to the internet, or to use the correct terminology, their WAN connection.
WAN connection, okay.
So in hot standby mode, both routers actually share the same WAN connection. So think of it like two roommates sharing the same internet cable.
Right.
Only one router is actively using the connection, while the other one is passively monitoring and staying synchronized.
Got it.
If the primary router fails, the secondary one immediately takes over and starts using that shared connection.
Okay, so kind of like having a designated driver, but there's a co-pilot who's always ready to grab the wheel.
I like that analogy.
What about active standby?
So in active standby mode, each router has its own dedicated WAN connection.
Okay.
So it's like having two separate internet lines coming into your house.
Right.
They operate independently, with the primary router handling all the traffic.
Got it.
If the primary router fails, the secondary one seamlessly switches over and starts using its own dedicated WAN connection.
Okay, so active standby, That offers even more redundancy because even if one internet connection goes down, the other router can still keep things running.
Precisely.
Okay. And I also see that they mentioned load balancing with active standby.
Yes.
Is that what I think it is?
Yeah, that's exactly what you think it is.
Awesome.
So load balancing allows the routers to distribute traffic across both of those WAN connections.
Okay.
This optimizes the performance and prevents any single router from being overloaded.
Right. So kind of like having 2 lanes of traffic instead of 1.
That's a good way to put it.
Keeps everything flowing smoothly.
Absolutely.
So let's unpack exactly how all of this comes together with DrayTek's high availability solution.
Okay.
Now, the document lays out several key elements that make this system work.
Right.
So first, you have high availability groups.
Yes.
So this is where you define which routers are working together as a team.
That's right.
And you can have up to 10 routers in a group
We can.
with one designated as the primary and the others as backups.
Exactly.
So you're kind of forming a squad of routers,
yes.
each with a specific role to play
Correct.
to keep the network going.
Uh-huh.
Then you've got priority IDs.
Yes.
So each router is assigned a priority ID, and the router with the highest ID becomes the primary.
That's right.
So this ensures that there's always a clear leader,
Exactly.
and it prevents conflicts.
Absolutely. So it's almost like a digital pecking order.
Right.
The router with the highest ID gets to call the shots.
Okay, it makes sense. And of course, security is super important.
Of course.
So they use an authentication key to encrypt the communication between the routers.
That's right.
And that ensures that only authorized devices can join this high availability group.
Exactly.
So that prevents any unauthorized access and ensures the integrity of the whole system.
Absolutely. It's very important.
Now, they also mentioned something called synchronization.
Yes.
So what is that all about?
So synchronization is really important for seamless failover.
Okay.
What happens is the primary router continuously copies its configuration settings to the backup routers
Okay.
so that they're always up to date and ready to take over if needed.
Got it.
This includes things like firewall rules, routing tables, even VPN settings.
So they're like a troop of perfectly synchronized swimmers, moving in perfect harmony, always ready to seamlessly replace each other if needed.
That's a great analogy.
And what about dynamic DNS updates? I see that mentioned as well.
So dynamic DNS or DDNS,
Okay.
that's how DrayTek handles situations where you have a dynamic IP address from your internet provider.
Okay.
So one that changes periodically.
Right.
What DDNS does is it ensures that your network remains accessible even if your IP address changes.
Got it.
It's like having a virtual address that always points to the right physical location no matter how often you move.
So even if the numbers behind the scenes are changing, the network address stays consistent.
Exactly.
That's really cool. And I also see this feature called WCF license sharing.
Yes.
What's that all about?
So that's a great cost-saving feature, especially for larger deployments.
Okay.
So in hot standby mode, you only need one web content filter license for the entire high availability group. So instead of having to buy separate licenses for each router, you can cover them all with just one.
That makes sense.
Saves you money and administrative headache.
Yeah, no more juggling multiple licenses.
Exactly.
So DrayTek's got you covered there.
They do.
Now, I see the document also mentions some specific features for their Linux-based routers.
Yes.
Like the Vigor 3900 and the Vigor 2960. What makes those special?
So those routers offer some more advanced features that let you fine-tune your high availability setup.
Okay.
So for example, they have what are called advanced preemption modes, which give you more control over how the primary router reclaims its role after it's recovered from a failure.
Okay.
You can choose things like immediate preemption, delayed preemption, or even manual control.
So you have a lot of flexibility in how you manage the leadership transitions.
That's right.
They also have LAN port detection.
Yes.
So the primary router is constantly monitoring its LAN connections.
And if any of those connections go down, it will trigger a failover to the secondary router.
Right. So it's like a built-in safety net to make sure that even local network issues don't disrupt connectivity.
Exactly.
Now, I'm really curious about this video demonstration. Can you tell us more about it?
Sure. So the video demo shows how all of this works in a real-world scenario.
Okay.
They've got 2 Vigor 2925 routers set up in a high availability configuration.
Okay.
Connected to a switch and a shared internet connection.
Got it.
They're using the ping command to send test packets to Google's DNS servers,
Okay.
which is a common way to measure network responsiveness.
Okay.
Then they simulate a router failure by physically disconnecting the power cable.
Okay, so they're really putting it to the test.
They are.
What happens next?
So the secondary router kicks in immediately and takes over within 3 seconds.
Wow.
Which is incredibly fast.
Yeah, that is impressive.
And when they reconnect the power to the primary router, it reclaims its role in about 1 second. So the entire failover and recovery process is super smooth and almost instantaneous.
That's amazing. It really shows how this technology can keep critical systems online.
It does.
Even when there are unexpected failures.
Absolutely.
So it really minimizes disruption for users.
Yeah.
And makes sure that everything keeps running.
Exactly.
Now, seeing this in action, that's just the first step.
Yes.
Wouldn't it be great to know how to actually set this up yourself?
That's right.
But for that, you'll have to join us in part 2 of this deep dive.
Absolutely. Welcome back to our deep dive into high availability networking with DrayTek routers.
All right, I'm ready to get into the actual nuts and bolts of how to configure all of this.
Okay, so let's demystify this setup process a little bit.
Okay.
We're going to break it down into easy to follow steps.
Okay.
Focusing on the most important settings and why they actually matter.
Sounds good. Where do we even begin?
Okay, so the heart of the configuration lies within the router's web interface.
All right.
It's kind of like your control panel where you can tweak all the different settings.
All right.
So you're going to first navigate to the Applications menu.
Okay.
And then select High Availability.
Applications high availability. Got it. What's next?
All right, so now you should see a section called Redundancy Method.
Cool.
And this is where you choose between hot standby or active standby.
Right. Remember those roommates?
Exactly.
Sharing a WAN connection or having separate WAN connections?
Yeah, like those understudies sharing the stage or having their own separate rehearsals.
Perfect analogy. So I pick my mode then. What?
Okay, next up is Group ID.
Okay.
Now, this is a numerical identifier,
Right.
kind of like a team jersey number,
Right.
that tells the routers they belong to the same high availability group.
Okay.
So make sure all the routers in your setup have the same group ID so they can communicate and work together.
So it's like giving them matching jerseys so they know who's on their team.
Exactly.
And what about those priority IDs we talked about earlier?
Absolutely, you're right. That's crucial too. Remember, the router with the highest priority ID becomes the primary,
Right.
the leader of the pack.
Right.
So you'll assign a unique priority ID to each router in the group,
Okay.
ensuring that there's a clear hierarchy and preventing conflicts.
So higher priority, like a ranking system.
Precisely. And then, of course, let's not forget about security.
Right.
You'll need to set an authentication key.
Okay.
This is basically like a shared secret password
Got it.
that encrypts the communication between the routers.
Right.
And this prevents unauthorized access and ensures that only trusted devices can join the high availability group.
Keep those hackers away.
Exactly.
What about the management interface setting?
So the management interface that defines how the routers will communicate with each other.
Okay.
Behind the scenes,
Okay.
you typically choose a LAN interface
Okay.
that's less likely to experience interruptions.
All right, so it's like a dedicated back channel.
Yeah, a VIP lane just for the routers.
Perfect.
And then if you happen to be using a dynamic DNS service,
Okay.
you know where your IP address changes periodically.
Right.
Make sure you enable the Update DDNS option.
Got it.
This will ensure that your network remains accessible even if your IP address is changing.
Right. Keeping that address consistent
Absolutely.
so everyone can find you.
Yeah, and then now comes the exciting part. You actually enable the LAN subnets that you want to include in your high availability setup.
Okay.
Think of it like choosing which parts of your network get that VIP treatment
Right.
with the added protection of redundancy.
So you choose the networks that need that extra layer of protection.
Exactly. And then finally, the pièce de résistance,
Okay.
setting the virtual IP address.
Yeah.
So this is the shared IP address
Right.
that all the routers in the group will use for the enabled LAN subnets.
Okay.
It's the address that your devices will see as their default gateway,
Okay.
the entry and exit point for all their internet traffic.
And that virtual IP address, that's really the key to seamless failover.
That's exactly.
If the primary router goes down, the secondary one takes over with the same virtual IP, and nobody knows the difference.
That's right.
The network just keeps humming along.
Exactly. You've got it.
So once I've configured all of these settings on the primary router,
Yes.
I need to do the same thing on the secondary router.
Yeah.
Do you making sure they have the same group ID authentication key and virtual IP address?
That's right.
The only difference is the priority ID.
Exactly.
which will be lower on the secondary router.
That's correct.
Okay, so mirror those settings, just adjust the priority ID seems pretty straightforward.
It is.
But what about those Linux-based Vigor routers like the 3900?
Okay.
You mentioned that the process is a little bit different for them?
It is a little bit different.
Okay.
So the concepts are the same,
Okay.
but the interface and some of the steps are slightly different.
Okay.
So with the Linux-based routers, instead of configuring each router individually,
Okay.
you do most of the configuration on the master device, the one that's going to be the primary.
So it's like setting the rules for the whole team from the captain's chair.
That's a great way to put it.
Okay.
So you start by going to the Applications menu,
Okay.
then High Availability,
Okay.
and then Hot Standby Profile Setup.
All right.
And here you'll choose the LAN profile for high availability.
Okay.
Set the priority ID, remembering that lower is higher priority in this case.
Okay. Interesting.
You configure the virtual IP address for the network
Got it.
and input the group ID, that team jersey number.
Right, right. Okay, so similar settings to the DrayOS routers, just kind of grouped differently.
Exactly.
And then what about those global settings you mentioned?
Okay, so the global settings are found on the Hot Standby Global Setup page.
Okay.
And here you will enable high availability, select Hot Standby as the redundancy method, and input that same authentication key that we talked about earlier.
Sounds familiar. Anything else on this global setup page I need to know about?
Okay, so a couple things.
Okay.
You can choose the preemption mode here.
Okay.
And this dictates how the master router reclaims its role after it's been down.
Okay.
You've got options like immediate automatic delayed or manual.
Got it.
So it gives you a lot of control over how that transition happens.
Okay, so you can customize how the primary router makes its comeback.
Exactly. You also want to enable WAN connection status detection.
Okay.
And select the appropriate LAN port status detection mode.
Okay.
This basically gives your master router the ability to monitor both its internet connection and its LAN ports for any problem.
Okay, so always good to have those checks and balances in place.
Absolutely.
So I've got my master router all set up and ready to go.
Yeah.
What about the slave router? Does it need the same level of configuration?
So one of the nice things about this system is that a lot of the configuration is actually automatically synced from the master to the slave router.
Okay.
However, you do still need to tweak a few things on the slave router.
Okay, like what? Don't leave me hanging.
Okay, so first you'll need to change the IP address of the HA LAN on the slave router to a different IP than the master.
Okay.
Think of it as giving them separate addresses in the same neighborhood.
Right.
Only the HA LAN needs a different IP.
Okay.
The rest of the LANs can share the same IP.
Okay, so give those management interfaces different addresses.
Exactly.
But keep everything else the same.
Yeah, and then next you'll go through those same Hot Standby Profile Setup and Hot Standby Global Setup pages on the slave router.
Right.
Make sure the virtual IP group ID and authentication key all match what you set on the master.
Okay.
The only difference is you'll give the slave a lower priority ID.
Right.
Acknowledging the master's authority.
Right.
And since it's in hot standby mode, sharing the WAN connection with the master, you'll actually disable both the WAN connection status detection and LAN port status detection settings on the slave router, just to avoid any confusion.
So after all that, we connect the slave router to the master, and the magic of synchronization begins.
You got it.
Okay.
The slave router will actually back up and restore most of the master's configurations.
Okay.
Which makes setup a lot easier.
That's awesome.
Just be aware that things like the LAN IP, the HA configurations, the administrator password, and the router name, those won't be synced.
Okay.
Those need to be set individually.
All right, good to know. I'm taking notes.
Good.
Now, what about firmware upgrades?
Okay.
Do I have to manually update both routers every time there's a new version?
So that's another area where DrayTek makes things really easy.
Okay.
With the Linux-based routers, when you upgrade the firmware on the master, the slave automatically downloads the same version from the master and upgrades itself.
So they're in sync even when it comes to software updates?
They are.
Wow, that's awesome. So no more manually updating each router individually?
Nope.
Huge time saver. So that keeps both routers running the same software, which is super important for seamless high availability.
Absolutely, very important.
So we've configured both our DrayOS and our Linux-based routers for high availability.
Yes.
But how do we know if it's all working? How do we keep an eye on things and make sure our setup is healthy?
That's a great question and a perfect segue into the next part of our deep dive.
Okay, so for that, you'll have to join us in part 3. All right, welcome back to the deep dive. We've talked about what high availability is, and we've even gone through how to set up those DrayTek routers.
That's right.
But just like a well-tuned engine,
Yeah.
even the most robust systems need those regular checkups.
Absolutely. Monitoring your high availability setup is key to its success.
So where do we find the dashboard for our high availability network? How do we check its pulse?
Well, DrayTek provides some excellent tools for monitoring your setup.
Okay.
For both DrayOS and Linux-based routers, you'll find the high availability status page under the diagnostics menu.
Okay, diagnostics, got it.
It gives you a comprehensive overview of how your system is performing.
Right, so I'm in that high availability status page. What should I be looking at? What are the signs of a healthy system?
It's kind of like a roll call for your routers.
Yep.
The status page will list all the routers that are in your high availability setup, each with their vital statistics.
Yeah.
You'll see their priority IDs, you'll see their current role, like whether they're the master of the backup or maybe in some transitional state, their IP addresses, and most importantly, the status indicators.
So green lights for good, red flags for trouble.
Exactly. Green is good, red means there's something that needs attention.
All right.
You'll also see information about the cached time.
Okay.
This tells you how long it's been since the configuration was synchronized between the routers.
Okay.
So a long cache time might indicate there's a problem with communication, and you might want to look into that.
Okay, so I'm scanning the status page looking for any red flags or long cache times. But what if I want to get even more detail about a specific router?
So that's where the details link comes in handy. If you click on that, it'll take you to a page dedicated to that specific router.
All right.
You can see things like the firmware version, WAN, connection status, LAN port status, and a whole bunch of other parameters.
Okay, so it's like a medical report for each individual router.
Yeah, it's a good way to think about it.
All right, so I'm checking the high availability status page. I'm scanning for red flags. I'm diving into the details when I need to. What else can I do to keep my high availability setup running smoothly?
Just like with any well-oiled machine, you need to do some regular maintenance.
Right.
One of the most important things is keeping your firmware up to date.
Okay.
And remember how DrayTek makes that easy, especially with the Linux-based models where the slave automatically updates itself?
Right. Huge time saver.
Yeah. For those DrayOS routers, though, you want to periodically check for firmware updates on DrayTek's website.
Okay.
They release updates pretty frequently to fix bugs, improve performance, and they often introduce new features.
Makes sense. You got to keep things running smoothly.
Absolutely.
What else can we do for maintenance?
It's also a good idea to periodically test your failover process.
Okay.
You know, kind of like a fire drill to make sure everything's working the way it should.
Okay.
You can simply unplug the power to the master router
Okay.
or disconnect its WAN connection.
All right.
This will force it to fail over to the backup router.
Okay.
And then you can check that high availability status page
Got it.
to make sure it actually happened the way you expected it to.
Okay.
Then you can power the master router back on and watch it reclaim its role.
Right. So your network traffic should keep flowing without any interruptions.
Like a well-rehearsed orchestra.
Right.
Even if one musician takes a break.
So those tests are like dress rehearsals for the real deal.
Exactly. That's a great way to put it.
Any other tips or tricks we should keep in mind as we go down this high availability road?
One thing that's often overlooked but incredibly important is documentation.
Right.
You want to keep good records of all your settings. IP addresses, priority IDs, authentication, key, any customizations you made.
So it's like having a blueprint.
Exactly. If you ever need to troubleshoot a problem or restore your configuration.
Like an insurance policy for your network.
Precisely. You hope you never need it, but you're glad you have it when you do.
Absolutely.
Right.
And remember, high availability, it's not a set it and forget it solution.
Yeah, it's not.
It needs those checkups, the regular maintenance, and sometimes a little bit of troubleshooting.
That's right.
But if you give it a little bit of care and attention,
Yeah,
it can provide some serious peace of mind.
absolutely.
Knowing that even if something unexpected happens, your network is going to stay online.
Exactly.
So for anybody out there who relies on that constant connectivity,
Yeah,
whether it's your business, your essential services, or just a really important gaming session,
right.
high availability networking is something you should really look into.
Absolutely.
It's amazing technology. It's really a testament to those engineers who design these systems to keep us all connected no matter what.
It is. And the world of technology is constantly evolving. There's always something new to learn, so keep exploring.
Thanks for joining us on this deep dive into high availability networking.
It was my pleasure.
We'll see you next time. Keep those connections strong and those networks humming.